All right, in today's video, we are going to be vaulting our ceiling. That requires two things, insulation and structure. We are going to go through the whole process, how to get this all sealed up and buttoned up, but more importantly, how to remove these collar ties so you get that great open space. One of the most important aspects of doing a vaulted ceiling is when you're converting an old house like this into modern day construction, you really want to take consideration of your insulation factor. And insulation, no matter if it's mineral wool or fiberglass, it's really restricted by how deep your cavity is. So the original 2x4 inch, which is an actual 4-inch, isn't thick enough to get R20. And that's really the goal here, is to get an R20. So what we're doing is we're adding 2x2s. We've put an angle on it so that we can have this here just nice and tight. We're going to continue this down and build out the wall so we have R20 all the way through our area. The other major factor when you're vaulting a ceiling is the collar ties. Now these pieces here are really designed as part of the structure, and it keeps the roof from falling apart, right? Now in our situation, I'm bringing in a structural engineer. We have got a lot of different options that we can employ here. We can put in metal brackets at the peak. We can remove some of the collar ties and double up in certain areas. We can also beef out our wall here, which is what we're going to do with 2x4s horizontally. So we get a lot more strength in this wall so it doesn't bow and flex. And that can reduce us down to needing only maybe 2 of them. So what I'm going to do is I'm going to frame it the way that I'm pretty sure my engineer is going to approve it. And then we'll bring him in and do a quick walkthrough. And then he can put his stamp on the work that we've done. And if he wants to do any modifications, he can let me know at that point. But the basic foundation is this. You got to get enough depth to get R20, so you need 5.5 inches. And you want to have a structure that's structure. This is kind of the fun what we're dealing with. We opened up this ball of wax here. You should not be able to rip apart your house with your bare hands, folks. Man, oh man, oh man. There's just nothing holding any of this together. Wow. So what we have to do is we have to cut this out. We need to cut this out. We need to remove this. We want to put in a new top plate, structure it all up, tie it into the existing frame. That way, when we go to the outside and do our siding, we can have something to tie in the new boards, because this will all have to be replaced, but a lot easier to do that from the outside. And since we're going to open that up anyway, we'll save that for a later date. Once we get it all reframed, then we can insulate. We're going to come over with a plastic 6mm vapor barrier. We're also going to use acoustic sealant to get an air seal. Nothing about this house was made to control moisture or air. So we have a lot of work to do, but the steps are simple. And if you follow this kind of procedure, you're going to be able to re-insulate and seal up any area in the entire house. So my goal right now is just to finish restructuring so then I can get into insulating. So what we're going to do, and this is the beautiful thing about balloon construction, you just cut it back to where the wood is solid and then reattach and laminate everything together. It's not that tricky, just a little time consuming and a little bit of fun. I think 48 was about here, eh? One of the best things about this kind of structure, there's just so much wood involved here. Even if you cut too far, there's another layer and another layer and another layer. So, there we go. That's good solid wood there. We'll save that. We've got to cut this out. Because it's open cavity, I can actually stick my other piece of wood all the way down there and then just bring it up to this plate after I've reinstated it. So we're just gonna leave that there because it's not in the way. It is something we can laminate to. Just to give you an idea. So this is the board, the beam that's coming up from the basement. And it stops shy of the plate. So then they just grab another piece, just stick it on, a couple of nails. What we're gonna do is we're gonna get rid of that. Ooh, we need a bigger tool. Let's get rid of the top first. You'll see, that's just insulation. Wow. Okay. So what's going on is every one of these boards is nailed from the outside into this. So the only way to remove it is to peel it off this way, but it's also nailed into that. And that's where the structural strength is. Everything's nailed in more than one direction. Woo! We might find that we're actually going to be in better shape leaving it alone and laminating this, and then just rebuild. Understand that wood isn't the greatest insulator in the world, but it's not terrible. And since we don't want to have to tear apart half the house in order to rebuild this, probably our only option at this point. The original wood here is actually 2x4, and it's an actual 4-inch. So what we did is grab some 2x6s and ran them through the table saw just to create an actual dimension. We're using a little bit over 3-inch clipped head nails, so if you put them on an angle, they won't fire out the other side. So now it's time to put in our new beam and tie it into the old structure. Well, this is where it gets interesting. You can see here the difference in the thickness of two pieces of wood, old and new. What we want to do is we want to match the top. Over here. Okay, that's temporarily in place. Because it's balloon construction, they actually put the floorboards and cut around these beams, just like doing a deck. And they're in our way for two reasons. It keeps you from getting a consistent thermal break. Now when I insulate, I can actually get right down into this cavity from before. It also gives me a little bit of flexibility for doing all this. So being balloon construction, our goal is to transfer load and to tie everything together with good nails that have shear strength that'll keep it all stable. And then you tie all the framing lumber together with the siding, the original wood siding. So we're actually going to bring support up to underneath the new plate here. And the way I'm going to do that is by adding a block here with all those nails, gives it shear strength. And then I can bring this up, right up underneath it. Now, I am not liking the twist of that board. So I'm going to incorporate a lever here. Okay. I'm having issues with getting enough leverage to twist that board and get it in place. So what I'm going to do is I'm going to add this board on the side and use this as my lever point. Here we go. This should demonstrate the strength of that, shear strength of those nails. Oh, there we go. That's taking the weight now. There you go. So our goal is not to lift the whole house, it's just to create a nice solid contact. Now the last thing we have to do is reintroduce this bad boy here, but where it's separated from the outside, there's just no fighting with that. We're going to lose that battle. What I want to do is I want to cut everything back that's separated from the other roof and then reinstate a new one. So we'll cut through it first. Yeah, that's awesome. Great opportunity to see these old original nails. Okay, so it's just a triangular spike, and that's it, but it does the job, eh? Just a thought when you're working on your house. This is a really good time to mention not to be too creative. If you're working with old wood structure, use wood to solve your problems. If you're working with stone, use stone. Don't mix materials and technologies. It's really not a good idea when you have something that's, let's say, 800 years old and you're using a welding torch. Just saying. Yeah, that looks pretty good. I'm just trying to translate my angle there. so I can pass my wood right down on top of that plate and get pretty good contact. It looks like it's going to be pretty good. I like it. So my trace line was pretty close to 45 degrees, so I just cut it on 45 degrees. I'm looking at the design of this and I'm thinking, yeah, it kind of has a triangle shape. Most likely this will work. I know that in the old days, they kept their designs and cuts pretty simple. So here we go, right? That looks pretty good. Now the heel of this is sitting nice. The back is open, but it's because the roof is caved in here. So what I'm going to do is I'm going to start by nailing here, and I'm going to slowly lift up here and then nail across as I get it nice and flush. That'll straighten the whole thing right out. I got a few nails left. Okay. Now let's remember, because of the sheer amount of wood that's been going on here, this area of the house completely rotten with almost no structural support, and yet people have been getting up and down a ladder out here to change our internet service multiple times and not falling through the roof. So don't be too hard on yourself here with how much contact you get. The goal is to make sure that this is nice and flush outside, and then the first nail is the one that you're going to work off of. There we go. Here we go. Yeah, here's my little trick. Just one nail for this one. Okay. Into the existing, into the new wood. There we go. That should give me just enough up there that I can lift that whole roof into place, and it will. All right. Woo! Now, if anybody ever wants to know how to DIY, simplest answer is blood, sweat, and tears. Here we go. Well, we're all reinstated. That didn't take much effort at all, huh? With the roof, with the front wall, with the exterior. Perfect, that's money in the bank. That took us, what, 2 hours? Now, had somebody done that a long time ago before they put the new siding on the house, I wouldn't have run into this mess. Wouldn't have been quite as much work either. Anyway, that's what you can expect when you open up these old pigs. There's always somewhere in the house where something's gone wrong. Time to insulate. Here we go. So in our plan, of course, we're going to put these 2x2s on the ceiling. That brings our height down to here. So what we're looking at doing is doubling up the strength of this wall by putting this piece across the bottom. And this represents the new depth of insulation. And we'll put another 2x4 across here around this point. All right? And that also will become the depth of insulation. And then we'll add 2x2s in the gap. My 2x2s are going to be 35.5. One of the things you'll find with older construction is the foundation might have moved around a lot, but you know, the guys that build stuff had a fair amount of integrity. So usually the measurement at one end is the same at the other, even if the end is moving up and down. All right, well, let's get suited up and get all this nailed on. Remember, our goal is to set this up so that my structural engineer can come through and agree to get rid of all these collar ties. We'll see. Sometimes that works, sometimes it doesn't. Depends on the engineer, depends where you live. And sometimes depends on how the sun is shining on the day of the visit. Nothing about building old houses is consistent, that's for darn sure. Right, so we're just waiting for the structural engineer now so we can have our conversation about the collar ties, and then we can finalize our plans on the rest of our structure. As soon as we have that all finished out, then we will finish framing, and then we can insulate and get this all vapor barriered up. It'll be so nice to be separated from the old crud in the walls and the bugs and the dirt and be in a clean space. I just cannot wait. But first, we get to get the collar tie sorted out. So I'm here with my structural engineer, Ethan from Star Engineering. I've been using Star Engineering for the last few years. Ethan, this is the first time we've met.
Yes.
Okay, I usually was working in the east end of Ottawa, so I worked with the guys out of the other office.
Okay.
Okay. We're in the loft here, and we want to get rid of the collar ties, and that's these big things up here. And I was just having a quick conversation with Ethan about if I want to open the ceiling completely to the top, you're suggesting a ridge beam, and we can put one underneath all of the points of this ceiling?
Yeah, your best bet here is to put the ridge beam up right tight to the right underneath the peak.
Okay.
And then that will run all the way to
the outside balloon wall?
Yeah, the outside of the house here.
Now that's balloon construction. How much do I need to be able to carry that down?
It depends on the size of the beam,
okay,
on how much weight is on the beam. So if in this case we're maybe 20 feet or so, you're probably looking at a 4 2x6 post, somewhere in that range.
Okay, so then I'm going to have to open up enough of this space to get a 4 2x6 post down, right down to the bottom.
Yeah, it's going to have to be continuous from the peak of the roof all the way down and supported on the foundation.
Foundation. So
Yeah.
the last floor joist in this package won't be good enough? It has to go right to the foundation?
So it can be done in 2 separate posts. One,
Okay.
one from the bottom of the
Here
beam
to here?
to
and
the
then
floor level,
one from there down.
and then underneath the floor down to the foundation.
Okay, that's a lot of work. Fair enough. And then over here, we'd bring this over here. Now, I've got plans for a Murphy bed in here and a bookcase.
Okay.
So if I was to bring up a structural post here and here, and then carry it across, bring it down, does that work?
So to do a post beneath the beam.
Bring a post down
here.
and then carry it over to 2 other point loads onto the...
Not a problem at all.
Okay.
You can do it that way, and there's an opening below us under this wall anyways.
Yeah, so the structural support for that opening is behind this cladding here. So I actually want to bring all that load onto that part of the wall behind this cladding then directly, right?
Yeah, that's the best way
I just
to do
need
it.
to cut open that roof, which is the existing roof. Can you believe this? We'll cut this open, find that beam, and then bring that load to there.
Yeah, same sort of idea on this side. You have a post from the bottom of the beam, and it can come right into this wall. You have to cut a strip down here.
Yeah, yeah.
So you can do that. Or like you were saying, you can do a beam across with 2 posts.
Okay, so I actually want to restore this so I can open up from the other side to get my beam in.
Not a problem.
Okay, good.
Yeah.
Now, if I wanted to not put in a ridge beam, I've actually seen a couple of different options. I've seen people put in like steel L's and just tie that all together so that it can't flex and bolt through the wood. Is that an option?
It's something we can look at. It's
Okay.
a little more design intensive,
Right.
because essentially right now we have these collar ties nailed into all of the rafters.
Sure. And we're asking a lot from this really 140-year-old wood
Exactly.
under nut and bolt.
And it's a lot it's a lot easier to hold it together when you bring this tie further down.
Okay,
So
so the
if you
lower
want-
it is, the more strength you get.
Yeah.
So the more ceiling I want, the more engineering I need, basically.
Yeah.
So if I was to sacrifice, let's say moving the collar tie up 2 feet, okay, and put the collar tie in at that point, I'd be looking at going more like 2x10 or 2x12, maybe galvanized bolts 2 times.
That's the idea.
Is that a doable option?
It's something I'd have to design back
Run the
at
numbers?
the office, but it's definitely feasible.
Okay, so then I could go with a ridge beam for full exposure.
Yeah.
It's labor intensive.
Yeah.
Or we could maximize a little bit of headspace and get more of a 9 or 10 foot ceiling here with something a little bit simpler. Okay, I'm going to probably look at both options just because I'm curious.
Yeah, we can definitely look at both.
Oh, awesome. And is there anything, like what we're doing over here, we're basically adding wood so we can get proper insulation, and we want to go to R20,
Yeah.
okay? But we're adding this 2x4, and this 2x2 here, we actually cut on a 45 so that all of this downward force is sitting against that wall. We're just trying to give a little bit more rigidity in this thing. That doesn't factor into your equation at all, does it?
It's really not, because these So these roof rafters now, we're not changing the span at all.
So it comes to span and load and
Everything
winter
is kind of grandfathered in because we're not adding anything new.
Okay.
So because it's existing, we keep the support essentially the same. So it's supported at the top and at the end.
Okay.
So anything you add, whether it's to increase the insulation or just add some extra
That
nails
doesn't change your math.
and rigidity, it's not going to change any design that I have to do.
Now, quick question, because I have a crazy plan for the future, Ethan. I would love to cut a piece of here and open up a dormer.
Okay.
All right?
Yeah.
If I'm thinking of doing that in the future, is there anything I should do now in advance of that so that the structure's in place? Like if I was to put in a dormer starting tomorrow, what does my structure require? Obviously, 2x6 doubled up.
You're going to need a double up at each side of the dormer. That's
Each
right.
side, anything across where I'm going to cut and pivot? Like let's say I want to go to 8 feet and then that's where it's going to lift from.
Yeah, so you'll have a cross beam wherever the dormer stops.
Right.
So it'll go, let's say from here,
Here across.
you go across 2 or 3, however
is that a
wide
double
you
as well?
want it to be. Again, it depends on the loads.
Okay.
So it'd be something I have to design,
Sure.
but you're more than likely going to be good with a double 2x8.
Okay.
Something in that range, but it would have to be engineered.
So if I was to cheat and put in double 2x6 after the collar ties are gone on both sides, and then cut across a double 2x6 with joist hangers, so that next spring I can call you up and say, hey, this is what I did. Can I open this up? Are you going to need me to pull the ceiling open, or if I take pictures, is that enough, or should I engineer it now?
It should be engineered now.
Okay.
Most of the time with the permit process, you can include other items even if the work is not to be done right away.
Okay.
So you can have that included in the package,
Right.
and be specific and only work on this area or that area at a time.
Yeah, because the city only cares if you're putting your stamp on it at the end of the day.
The city is normally very fast at giving you your permit.
Yes.
Whenever we have already taken the
Oh,
responsibility.
because, yeah, that's why they have rules, right? Listen, at the end of the day, the city has certain rules, and if you work inside their box, you're fine. They can approve it. As soon as you move outside the box, you need guys like Ethan to say, yes, we're good. Here's a stamp to prove it. We've done the math. You're safe. So we have the drawings back from our engineer, and Ethan was awesome. He gave us the design drawings for raising our ceiling up to 9.5 feet, which is, let's take a look up here. This point here is 8 feet tall. Sorry, 9 feet in the ceiling. So 9.5 feet would take us somewhere up around here. Now at this point, we're going to be putting in a 2x8 all the way across. And that is going to replace the existing collar ties, which were 2x6. The thing is this. We aren't going to get a full cathedral ceiling out of this because the engineering involved in that was absolutely ridiculous. That whole ridge beam would be a solid week of structural framing, and I really don't want to bring all this back down to the foundation wall and trust that not to be moving because it's stacked stone and shallow ground on the one side. So if this is foundation buried 8 feet deep and that's foundation buried 2 feet deep, there's going to be an unevenness going on with the heaving in the wintertime. So the best thing for me to do is to bring it down to the structural wall and let the whole addition raise and lower a little bit together in the winter. Having said that, now it's time to figure out what to do with this information. So remember, in our walkthrough with the engineer, he discussed that if we raise the collar ties, we have to make them thicker for more strength to hold this thing together. So we went from a 2x6 that was here to a proposed 2x8 at 9.5 feet. But the reality is this. That other 6 inches, that half a foot, it doesn't provide me any real value in this situation. If I'm putting in a flat ceiling across here at 9.5 feet, it gives me the same feeling of extra space and openness as it does at 9 feet, which is what this point is. Now at this point, I need 2 batts of insulation to finish. I've got 2 layers of drywall to finish, and my life is made really simple. If I take it all the way to 9'6", I have to cut a little bit extra lumber here to extend it. I've got to cut extra insulation to extend it. I've got to cut an extra sheet of drywall to extend it, plus an extra joint. It's an awful lot of work, double the work, just to get that other 6 inches. So what we're going to do is we're going to take this structural dimension for a 9.5 foot, bring it down, the same material to use it in the 9-foot, which makes that collar tie even stronger. And that way we can finish off our ceiling at the same place that building materials will finish off naturally and make this whole process so much more simplified. When you're making plans like this, sometimes you're going to be disappointed. You won't always get everything you want. But if you're going to make changes, think through the whole process from the beginning to the end to make your decision as to what you're going to do. Because getting rid of that extra 6 inches, okay, I lose a little bit of height. But what I lose in height, I'm going to save myself in an entire day's work just to get it installed to the drywall, plus an extra few hours of taping, plus the extra materials. I'm telling you right now, I'm probably going to save myself 3 or 4 days worth of work and the materials that I don't need. I'm still going to have a 9-foot ceiling. I still have the option to make this a walkout later. It's a win-win-win. So, thanks Ethan and Star Engineering for the information, but we're going to bring it down just a little bit so that everybody can be happy and we can get this job done on time and on budget. So the process that I'm going to use for installing these collar ties by myself is pretty straightforward. I'm attaching a 2x4 just across the ceiling where all of these are ending off on each side. And I'm going to be able to measure across, cut my collar ties in advance, set them all in place, and then just bolt them in with lag screws. The engineer spec calls for 1/4 inch thickness, 3 inch long, and that's what I picked up today. Once I've got all that done, we're ready to close. I'm also going to need a level here, Maddie. Let's have a peek at that. Holy shiitake. That's so weird. Wow. Here's the thing. This house started here, and it fell down, and it goes back up again. The wood is not laminated on any kind of a level plane. This says that's level. And it offends the mind, doesn't it?
No.
104.5. That makes sense because the floor is a lot higher here than it is over there. Okay. All right, here, this will work. You hold the marker. I'm going to go to the middle and read the bubble. And then you can mark where the top of the next 2x4 goes. On the fresh side of this corner here, Matt. Right off the tip. Dang. So let's screw the other 2x4 off of that tip and we'll level that one. And then we'll throw this on both extremes and we'll see if it keeps coming out. Here we go. Let's have the level and we'll try that out. Use the yellow one. So, all right. I feel like I'm building a floating deck here. All right. So what we've done here is we've just attached a 2x4 onto the top of the slope on each side at the extension of the the 2x2s. Just to give us a reference point. Remember, this foundation has moved a lot and there's nothing here that's square, level, plumb, straight, flush, nothing. It's a mess. It's like building a floating deck above your head. So we just created this level spot here on both sides and we throw the level on these boards and this says, hey, I'm level. But is it really? I mean, visually, it's very disturbing. It's really hard to look at this and go, oh, everything is normal. This ceiling's caving down, it's caving back up. Is the wood all curved like a hockey stick? I mean, the wood's pretty flat. This does not look normal. It's very confusing to the eye. You really got to get to a point where you trust this. If you're reading your level and it looks really messed up, flip it over, switch end to end. Like, if it says the same reading every time, it's not the level. It's just a trick of the eye. This is crazy. So we're going to just create a level point across the top at every one of these, and then we're going to cut our collar ties in, but what a mess, eh? Now we've got our level established. Dear Lord, we know we want to make our collar ties go from the outside of the sheathing to the outside of the other sheathing on the other side. So we can measure that distance, but then we got to add the angle. Looking at this place, you kind of think, yeah, the walls are on a 45-degree angle, the peak must be a 90. Well, that's what the square comes in for. This is really easy to double check. We are out 1 or 2 degrees. The assumption is it was 90 at one point. So what we're going to do is we're going to take our actual measurements, take off 1/4 inch, cut them all in 45s. And Matt, you're going to do this, right? You're just going to use this on the lumber, cut your angle, go from the other side, cut your angle. So I just got to get my measurements now, translate that down to Matt on the saw, and then we can stick all these in and bolt them down. All right, so for measuring across, we're going to gently set the tape on both of these. And I'm going to measure the height of the top of this tape. And I'm at 56.5 inches on the top of the tape. When you're reading your tape, I'm measuring across. And this is sitting on my board. I'm measuring 56.5. The tape is 1 inch thick. So if I'm 1 inch thick and it's a 90 degrees, I have to add 1 inch to each side of this measurement. This is the trick. So it may be saying 56.5. We're going to cut it 58.5. We take off 1/4 inch for good measure. 58.25. And I'll measure all of these first before I get off. I can read that from the ground, and then we'll start cutting. Hard to believe this is the same place that we were not too long ago. And we didn't even want to stick our head through the roof. That one actually says 58.5. That one's 60.5. 60.25. And I wonder if this one here is going to be 57.25, or is it going to go back up to 59.25? Ah, this is the house that insanity built. There we go. 58.25. Look at that, it leveled out. I feel like I'm a little kid again, you know. Somebody help me with my tie.
My collar tie.
Here we go. Okay. So obviously I can't install my collar tie into place with this brace here, so now that we got our measurement, that represents the top of my collar tie. All right? So I'm going to make this mark on both sides on all of these ties, and then we'll move the temporary brace out of the way, and we'll have to install it one at a time. So, our design calls for 1/4 inch lag bolts, but I'm just going to install this first with a couple of screws just to set it in place. Now, nothing that we're doing here is a perfect science, but there's our line. I like that. So now we got our brand new, the hardiest piece of wood this house has seen in 140 years. We're going to put it in with these lag bolts just to make sure that this sucker never decides to do anything different than what it's designed to do. There we go. When you're driving a lag bolt, drive it till it won't drive no more. All right. That is how you attach a collar tie. By doing that on every collar tie all the way across, we can guarantee that we can drive a dump truck on our roof. It's a far cry from those 2 little nails that the other guy did. All right. Yep, that works. Last thing we need to do for finishing off our roughing of our ceiling is to put our wiring back. Now, because I live where I am, I'm allowed to do my own wiring rough-in. We've already passed inspection. And generally speaking, as a rule, inspectors have no problem with you installing fixtures like this and leaving it dangling for future consideration. So even after they've come and gone, you're allowed to move this into place it where you want it, and then mount it, okay? It's amazing. As long as the wire is to the functional box safely, then where it gets located before or after inspection is really of no concern to them. It's a kind of a weird thing, but they'll allow you to make movements after the fact. They just wanted to come by and do an inspection. It's mostly just to make sure you know what you're doing, and they're confident you're not going to be a complete idiot and set your house on fire. Okay, so before I mount my box, I gotta find my center line because we're gonna hang a pendant. I'm 43 1/4. That's 21 5/8. What I'm gonna do is do this. 21 5/8. Right from there. Okay. That's what the end of that thing is for on the tape measure. And a couple of good solid flooring screws. There we go. Ready to drywall. Whew. First we got to insulate this bad boy. That's another video. If you like this kind of information as far as how to restructure and reframe a vaulted ceiling, then please subscribe to the channel. We do new videos. It's our favorite thing to do. If you have questions about this project, then ask in the comment section below. And don't forget to check out here. We're working on an 1880s farmhouse. If you haven't seen these videos from the very beginning, you're missing out. So join us on our wild ride as we renovate this whole thing top to bottom.